So, hello everyone, this is Deepak Joshi, and today we are going to solve this particular problem of GFG, that is problem of the day. The problem is print in bit binary number having more ones than zeros. I think if you are here, then you have already gone through the problem statement. The problem statement states that we have given an integer n, and what we need to do is we need to figure out the binary numbers which has more ones than zeros when we take their prefixes. What do I mean by this is, let us take an example. Let us have 2, which is already there in our example 1. For this particular 2, we can have either 1 1 or 1 0, which satisfies that we have more number of ones, more or equal to equal number of ones as compared to 0. Okay, and it should be done in the prefix manner as well. What do I mean by this? Let us separate them. For 1 1 1, I can have either 1 or 1 1. Both of these two binary numbers has more or equal number of ones compared to zeros. If I do the same with 10, I get 1, 1 as a prefix of 10 and 10 as the prefix of 10. Again, here both 1 and 10 have more or equal number of ones as compared to zeros. Okay, so I think problem statement and the given examples are clear to us. Now, how we are going to approach this particular problem? Honestly, it took me a while to figure out like how can I reach to the particular solution. After just having a glance of the expected time complexity and expected auxiliary space, I get to know that it has to be done in 2 raised to the power n time, or in this particular space. Okay, so what I need to do is let us take an example. Let us take a very short example. Let us take 2 as an example. If I need to do this thing manually, how I'm going to approach this particular problem? What I'm going to do is I'm going to start with 1. Okay. Then what I should do is I should have two conditions for this particular one. Next time means I have this one. Either I can add 1 to this, or I can add 0 to this one. Uh, So I have reached my solution. It's simple. Just start with 1, add 1 or 0. Both the cases are the solution of our example 2. Let us take this another example, example 3, and try to replicate our approach to this particular given example. Start with 1, okay, and then add okay, let us add 1 and then add 10. Okay, now what? There has to be 3 cases. So what I'm going to do is um 110. Okay, seems good. I have added 0, and I can also add 1, or either you can add 1 first and then 0. Okay, I have figured out 2 cases where the number of ones is either equal to or greater than 0, and with all the prefixes. Like, you can check for this 111. I can have 1 as a prefix, 1 1 as a prefix, and 1 as prefix. And for this 110, I have 1 as a prefix, 1 1 as prefix, and 110 as prefix. Okay. Now, for this particular 10, what I can check is I can add 101. I can add 1 to it, but I'm not able to add 100. Why is this thing is not allowed? Because if I add 0 to 10, it will become the prefixes will be 1, 10, and 100. This particular case does not satisfies our condition. Okay, why Deepak? Because there is the number of zeros are greater than the number of ones. Okay, so how I am going to eliminate this sort of condition? Whether to check that we are that how I am going to add 0 to the particular string or the particular binary number. Okay, It seems good. What I can do is I can have a counter which can count uh, which can count like how many extra ones do I have. If I have extra ones extra ones more than zero, then only I can add zeros. If I do not have any extra one, I am not going to add zero to that particular solution. Okay, how I am going to have the count of extra ones, Deepak? It's very simple. Whenever you add one, means for this particular three, I have added one. I'm going to have my extra one as one. Then I have added one more one here. I'm going to have my extra one as two. Okay. In this case, I have not added this. Okay. Then for this, I have added one. So my extra one will be three in this particular case. Here it will be two only. And this for this particular case, it will be two only. And for this particular case, I have my extra one as one only. So I'm not going to add anything to it because already extra one means currently I do not have any one added to this thing. It will be more clear if I will make you go through the code. Okay, let's try to implement this using recursion. Okay, then we will have the better idea of this particular solution. Okay, let us have a function. Let us name it as, okay, recursive function. Okay, you can name this anything whatever you want. It is going to take a string. I'm going to name it as answer, then a temporary string, and the extra ones that I have talked about, and the size means the n value which is given to us in the problem statement. Okay, simple, as simple as that. What will be the base case here? Now, what we are going to do is we are going to have the check on the size of the binary number. It means, let us say we have n as 4. Then, do I am I going to have more than four numbers in my binary number, or more than four digits in my binary number? No, I need to have only four digits. So instead of naming it as n, what I can do is I can name it as the total number of places, or number of places. Okay. Okay. So if I will keep decrementing the number of places whenever I add a 0 or 1 to the string. Okay, got it. Got it. So this is going to be my base case. Okay. Here, what I'm going to do is I'm going to check whether I have my number of places equals to 0. It means I've completely occupied my I have completely occupied my space. Okay. That means if I have completely occupied my space, the string or this temp variable is going to have the size of n. So what I need to do is I need to push my temp variable to my answer, uh, which is the vector of strings, and simply return from this recursion call. Okay. Now, initially what I'm going to do is I'm always going to start with 1. Okay, as I have mentioned in the example or the try run as well, that if I have n equals to 2, this is the value of n, then always I'm going to start with 1. Then I'm going to add 0 or 1 to the binary digit. Okay, so for this particular case, okay, okay. So for this particular case, what I'm going to do is I'm going to have this recursive, I'm going to call this particular function with the vector remaining as same. And in this string, what I'm going to do is I'm going to add one. Simple. If initially this string is empty, then it is going to have one. Okay, let me make it very clear to you. I'm here. What I'm here doing is I am creating a vector of strings and naming it as answer. Then I'm creating a empty, or instead of creating an empty string, I can directly call my recursive function, which is going to take answer, a temporary string which is initially empty. Then extra ones, I'm not going to pass any ones, extra ones to the function, because the recursive function has to add the first one and add it to the extra ones as well. Okay, and number of places will be n, because initially I need to fill n places. Then I need to return from this particular function with the vector of strings which I have named answer. Okay, that means my temporary variable will be a temporary string will be empty. In that case, it will, in the first case, it is going to contain one only. Okay, it means I have added a one. Okay, then what I'm going to do is I'm going to add it to the extra ones. Okay, simple. And my number of places has been reduced. Okay, because I have occupied one space. This is the case of adding one. Recursion will take care of all the cases. Okay, now what if I need to add zero? I can add zero in that case only if I have a one in the binary digit. Okay, what do I mean by this? If my extra ones are greater than 0, simple. If I have any extra one, okay, I can add 0 to my current temporary string. Okay, that means what that means is I need to call my recursive function again. Instead of having this, I can make it look cool. Okay, simply pass answer, the temporary variable, temporary string. This time I'm going to add 0 to my temporary string. Nothing is going to be nothing is going to happen with the extra ones, or is there be anything other than this? Listen, what do I mean by extra ones? Try to understand that extra ones is going to take care of the extra ones present in the string. What is extra here? The extra is the difference between the number of ones and the number of zeros. If I have this sort of string, in this particular case, extra ones will be 0 because I have two ones and two zeros. But if I have this sort of string, in this particular case, there is three ones and two zeros. So my extra ones is going to be 1. Okay, that is the only case I need to manage. So if I have added 0, that means my extra ones are going to be reduced by 1. Okay, okay. If some of you haven't got this thing, let me explain this to you again. Let us take this example. Okay, I have this case. I have five. The number of ones are 5, and the number of zeros are 3. Okay, if I add 1 0 uh, here, then what should happen is, okay, simple. Cool. Let it be the number of ones be 5 and the number of zeros be 3. Then extra ones will be 5 minus 3, that is 2. Okay, simple. As cool as that. What if I will add 0 to this? Okay, then my number of zeros is going to be increased by 1, that is 4. Then what I need to do is I need to add 1 here as well. Okay, so my extra one is going to be decreased by 1. Simple. So here, if I add any 0 to my temporary string, then my extra ones are going to be decreased by 1, and my as the 0 is going to take a place, so number of places is also going to decrease by a factor of 1. Simple. This is the code for the given problem statement. Let us try to have a dry run over it, and then we can run this particular problem, particular solution. Okay, so what I have done is I have created a vector of strings. and I'm making a recursive call to this recursive function. Let us solve this for n equals to 2, and let us check what is going to happen. Let me just remove these comments. Okay, initially this base case is not going to be hit. I'm going to have my recursive call, and what I'm going to do is add 1. So I have currently 1. Then I'm going to hit this case for 1, and I'm going to add 1 to it again. Okay, and it is going to hit this base case that hey, the number of places are 0 now, because I'm continuously decreasing the number of places as well. Okay, it is going to backtrack and then come to this sort of situation where 1 is there, and then it is going to check this condition that what is the count of extra ones. It is 1. Then it is going to call what? It is going to call 0. Okay, I'm going to add 0, and then again it is going to hit this base case and going to tell us that hey, number of places is again 0. I'm going to add it to my answer, and again retrace from this recursion call. Okay, now the initial condition is for 1 I have managed both the cases. Now then if I haven't done anything to it, I'm going to check whether this condition is going to take place or not. But initially I do not have any extra ones, so this condition should fail and it is not going to give us anything. It means it should the final answer string should contain 1 1 and 1 0, which is I think is the right answer. Okay, let us try to compile and run and check whether we have any compilation error or not. It's 5:11 in the morning. Okay, and my internet is working. Okay. Okay, so it has been submitted successfully. I hope you all have got this particular approach. If you have any doubt, feel free to connect, and I'll see you in any other solution video. Bye bye. Take care.